In this video, I'm going to talk about some of the modeling details for the second version of the vaccine clinic model. And so if you haven't watched the first video, not the overview video, but the detail video, you should do that because I'm not going to rehash all of the details from that one. Instead, what I'm going to do is just focus on the modeling differences that you see in this one. And so if I run this and let it go, you can see the primary difference here. Let me slow this down a little bit. That we see between this one and the previous one is that one, I have a pharmacy area here that is distributing the vaccine doses to the inoculation stations. You can see these changing color here, and that color change represents the getting low on vaccine doses. And so I've also, in addition to implementing the pharmacy, I've implemented inventories of those doses at the individual inoculation stations. And I've also done a couple of statistics, time-dependent statistics that keep track of the doses and keep track of the patients. So again, I went over that in the overview. I'm not really going to dwell on that here because what I do want to focus on is the modeling details. So again, the primary differences between this one and the previous one is that I've implemented a rudimentary pharmacy distribution area, which I'll talk about in detail. I've also completely changed the way the inoculation modules work. Instead of subclassing from the server object in the standard library, I have started from scratch using the processor model. If you've never used the processor model, one thing that you should do is you should have a quick look at how to do that. And so I can give you a reference to a video module that talks about that. Let me pull this up here. So if you just go to this address, this is my website, the Learning Simio Lab series, and just jump into Module 12. Module 12 has 4 videos, and the one we're interested in here is video 3. So this video shows a detailed example of how to use the processor model, and that will help you a lot in understanding what's going on with the inoculation module. So we have the pharmacy area, we have the new inoculation module with the inventory, and then we have the runtime statistics that we have. And so what I'm going to do in this video is go over the details of how I implemented all of those features. So let's start with the new inoculation model. And so you can see, inoculation module. I keep saying model in place of module and module in place of model. Sorry about that. You can see that what I've done, if you compare this to what we saw at least from the external view, I have an additional input node here. I also have an additional processing queue here, and then I have this label that shows my inventory level, how many doses I have in stock. And so what I'm modeling here is the patients coming in and then being taking up the capacity where they receive the inoculation, and that goes through the input node here. And then the input node on the other side, the new input node, I'm going to have the runner, which brings the batches of shots that are already, the doses that are already in the syringes, and that the runner's going to enter through the through this new node. So the implementation of this is fairly straightforward. As I said, I started with the processor object, and you can see here's the external view. And so the processor object just has these 2 nodes and then a square. And so what I did was I just added the symbol for the table, exactly what I did in the previous one where I had subclassed from the server. Then I added 2 things. I added this new input node. So this basic node is mapped to a station. And so as you watch that, if you understand how the processor works or watch the video that I referenced earlier, you see that when an entity enters through this node, this location type basically says what happens to it. And in this case, what it's going to do is it's going to move to a station. So if you look at my definitions, you can see I have the replenishment station. So the processing station you get when you create the processor, and then I created the second replenishment station, and then I created an inventory for the doses. An important part about this inventory is the inventory element exists in the object, but the material name you can see is a reference. So this material name is passed in as a property, and so the material dose is defined in the base model. And so you see that if I go back to my model here and select this one, you can see that I have the, let's see here, where is it? If I click on that, you can see here's the dose. So that defines the material element that exists in the base model. So back to our inoculation module, I have two processes. And so from the processor model, you get this one main process that's triggered when an entity enters the processing station. So when an entity comes in through the input node and is transferred to that processing station, that's what triggers this process. And so in the default one, you get the in transfer and the transfer. And so this is the logic that I added. So essentially what we're doing is we're delaying for the processing time, which is read from the table, because we're still using that data-generated modeling approach. So that processing time is passed from the table. We then, as a new part, we consume a dose from our inventory level. And then we do some checking on inventory level so that I can change the symbol. So this is where you see the symbol changing from their normal white color to when we start running low on doses, they switch to yellow. So that happens here. I just arbitrarily set that value as if you're greater than 4, then we're fine. If you're greater than 2, then we switch to yellow. Otherwise, we switch to red. And so you can see that I'm just making an assignment to the inventory state to make that happen. And so we had defined in the external view the additional symbols. And so you can see that I have, my 3 symbols of plain or white, I guess, yellow and red. And so that second process is the one that I added. And so this is the one where we have an entry for the replenishment. And so you end the transfer, you then delay for the replenishment time, which in this case, I don't have a parameter for, I don't have a reference property for this. I just arbitrarily set it at 30 seconds. And now instead of consuming a dose, now I'm producing a dose. And the quantity that I'm producing is passed in by the entity. So the entity representing the basket or the batch of doses has a property or has an entity state called replenishment quantity. And so that's set at the pharmacy. So the pharmacy determines what that replenishment quantity is. And then when the entity arrives at the inoculation station, it produces or uses the produce step to add that to inventory. Then I set the state back to the resource inventory state back to 0 so that I can have the normal color. And then I transfer the entity to the output node. And so the net effect, when you watch this run, what you see, let me go, I think the very first one happens here at the inoculation station 1. Happens pretty quickly, so we'll just zoom out here and watch that happen. It happens at, I think I have it about every 5 minutes, and I'm going to talk about that with when I get to the pharmacy here in just a second, but let's let that happen, and then I'll just pause it if I can catch that when it happens. Okay, so now we see the runner who has the batch from the pharmacy is going to come to this input node. So we continue running, and now you're going to see this number jump to 16. And so that's telling me that that quantity, the replenishment quantity, as you see right here, is set to 10. And so that is a model level property. And so that's something that we can experiment with. And so because of the consume step inside the inoculation module, when a patient entity can have a space, but if there's no doses, so if the inventory level is at 0, then that consume step is going to block, and the patient will be stuck here until that inventory quantity is replenished. And so that's the basic operation of the new inoculation module, where patients still come in exactly like they did before. The new part here is that we added that inventory element and this concept of replenishing the inventory, and then of course the symbol change to represent the module status. So next, let's talk about how I implemented the pharmacy. So the idea of the pharmacy is that we have a material, which we saw the reference to in the inoculation module. So here I am in the base model, so I have a material called dose. And so this is what I'm representing. Each dose represents one vaccine dose that is already in a syringe. And so the idea, or what the current model of the pharmacy does, is basically generates batches of those doses. So each dose, again, includes is the vaccine dose in a syringe ready to go to the inoculation module. And so at the clinic that we're modeling here in Auburn, there's a process that involves 4 people where you're taking the vial, and they're currently doing the Pfizer vaccine, so they're reconstituting. Then you have two different people who are taking the reconstituted vaccine and putting in syringes. And then there's one person who takes the syringe and does the labeling. So you have a 4-person operation. And so instead of modeling that level of detail in our current model, what I've decided to do is a little bit more simplistic or a little bit more abstract view, where what I'm going to do is I use a source object, and then I set a replenishment inner arrival time and a replenishment quantity, which I showed before was 10. And then I'm creating an entity called a dose basket, because again, at the clinic that we're modeling, they take the syringes to the inoculation stations in baskets. So what my pharmacy module does is simply periodically produce these these baskets that are then delivered by a runner to the inoculation station. And so let's look a little bit how that works. And so again, if you look at just the source object, I basically have two reference properties to do the specifying the inner arrival time. And then I have an event called stop pharmacy, which I'll talk about here in just a second. And then I have an add-on process where I created the entity. So let's just take a quick look at this created entity add-on process. So here it is right here. So the first thing I do is I set the value or assign that value to the model entity of replenishment quantity. So when it arrives at the inoculation station, we can use the produce step to add that many to inventory at the inoculation station. Then what I'm doing is I'm testing for the target. And so the way my model currently works is I have a target number of inoculations that you're going to do. And once I reach that target level of doses, I'm going to turn off the arrivals. So what I do is I use the decide step to say, have we arrived at the dose target yet? And if we have, then I fire the stop pharmacy event. And so if you go back to my source, you can see I have the stop pharmacy event that's going to be the stop event name. So as soon as that event is fired, this source object instance will stop creating baskets. Okay, so we do that. We check to see if we need to turn off the arrivals. Then we seize a runner, because the entity here that gets created by the source instance represents the basket. And so now I need a runner to deliver that batch. And so in my case, I'm using a fixed resource called runner. You can set the capacity. I have it just set for my testing at 1, but you can set that capacity to whatever you'd like. And then so after seizing that, then you assign the symbol. And I have a little symbol here. It's kind of hard to see, but I have two symbols here. And so the first one is the batch. So when the batch is created, this is what it looks like. So this is my basket when it gets created. Once I've seized the runner, though, I want it to now look like the person who's actually running it out to the inoculation stations. This is a pretty common modeling trick where I use one entity type, in this case dose basket, and then I have two different symbols so that it actually looks like two different entity types, where I have a basket and a person. In this case, it's just one. So the runner resource implements the capacity so that I can make sure I never have more doses being taken out than I do runners. So then the basket goes to the output node. So here's the output node. And you can see the logic that I'm using is I'm using a select from list. And this is what I call the rep list or replenishment list. So jump over into my definitions lists. My replenishment list is all of those replenishment inputs. So for my inoculation stations, these are the new input nodes that I created. So R input at inoculation 1, R input inoculation 2, and so on. So that's the list that I'm selecting from. And in this case, I want to send the basket to the inoculation station that has the smallest amount remaining. So that's what this selection expression does. It says smallest value candidate.inoculation module. So I'm casting the list element as an inoculation module. And then I'm looking at the doses, remember, which is an inventory element defined within that object, quantity and stock. So this is going to pick the minimum, the inoculation station with the minimum quantity and stock, and then it goes from that transfer node to either this one, this one, this one, this one, or this one, or it goes in preferred order in the case of ties. So then when the entity arrives at the node, as we saw before when I was showing the inoculation module, it then enters the module, it does the produce step, it changes the symbol index, and then it comes out of the output node, the transfer node, just like patients do. But the dose basket entity is using the replenishment sequence right here. So its movement is defined by the replenish sequence. So it basically says go to replenishment distribute, which is that transfer node, and then go to sync 1. And then so it's just going to go to the replenishment distribute, and then it's just going to come back down here, right here to sync 1 and is destroyed. And so as it enters sync 1, I have a sync 1 entered where I release the runner. So that whole process models creating a basket, seizing a runner, having the runner deliver the basket, then unload the basket, then the runner brings the basket back, and then the runner is released. So that implements the basic rudimentary pharmacy, and what it lets me adjust here is that replenishment batch. So you can see that I have here random uniform 3.5 to 6.5. So in our clinic, they were estimating about 5 minutes to do a batch. So this would give some variation around 5 minutes. And I have my replenishment quantity of 10. So every 5 minutes, I create 10 doses and deliver those to the inoculation stations. And so as we run it, let me speed it up here, speed it up to about 25. And you can see that you can see them moving. You can see these guys changing where they get down to below 4 doses and sometimes below 3 doses. I'm sorry, below 2 doses. And you can also see that we have these status labels that give the current dose quantity. So that is how the basic replenishment pharmacy works. The last thing that we have here is we have these 2 sets of time-dependent statistics. And so I have doses where I'm tracking the number at station. So this is the instantaneous number of doses at the station. And so you can see this behavior of up and down and up and down and up and down, which represents the delivery of a batch. And then we have the long-term average number of doses that is available on the floor. We also track some patient information. So I have the throughput. So this is the average throughput over time, where we define throughput as the number of patients per hour that have been inoculated. We also have the current number in. And so you can see this sawtooth pattern here also, which is indicative of our arrival process that I described in the previous video, where we have time buckets and we have a target number arriving at a time bucket with a no-show probability and a little bit of time variation, but you can definitely see that periodic arrival pattern. We then have the average number, just the average number of patients in the system. And then finally, of most concern to our clinic was the number of patients in this observation area, because they, of course, have to be spaced out. So finally, I'll note for this video is the next step that I'm going to try to do is enhance the animation a little bit. You can see that my observation areas, for example, I could easily set these to oriented point cues and then actually space these out 6 feet apart, which is actually what you would see in the clinic. Make sure that they fit or fit within the layout, and so all of that is relatively easily doable. It's just a little bit tedious, so I haven't done it in this because I wanted to get this video out there because I know a couple of people are looking at this and planning on using the base model to, at least as a design point for models that they're creating. So those are the differences that we see from the previous model. Again, I'm going to continue making enhancements, and as I do that, I will continue to post. One other thing that I meant to say in the beginning, so this is 2 separate models. This one uses I add the pharmacy and I've changed the inoculation module, but the other model is just a different alternative. So when you look in particular at the inoculation module, it's not that this one is necessarily better than the other one, it's just a different implementation. So you should think of that as just trying to figure out what you want to do to enhance your model. What types of behaviors would you like to implement? What types of statistics would you like to keep with respect to the inoculation module? And then you can decide, am I better off using the processor-based or the server-based? Because they both have, their relative advantages and disadvantages that you see as you do the modeling. And so before I forget, the actual last thing I want to show with this model is some enhancements to my experiment. So I added some additional output responses. So you can see the new controls that we have. I have the replenishment quantity, the batch interarrival time, along with the target number of patients. And then I also track the ending number of patients, the maximum. I already had the maximum in the observation area and the closing time, but I have the average number of doses, the maximum number of doses, along with the number of doses that we end up with. Because of the way our dose strategy works, I have a target number that I'm trying to produce, and I have a target number of patients that were invited to be part of the schedule, but we do have that no-show probability. And so depending on how many you produce and what you set the no-show probability to, you could have some potential ending doses. You could also have some ending patients. So if I have set the target dose is too small, and I still have the patients when the model ends or when the run ends, I still have some patients that you didn't have doses for. So those are two of the controls that you can use to set the parameters to get the optimal run configuration.